Hey guys, it's Mr. Riz, and we're going to do section 2.7, Proving Segment Relations. So we're going to learn a couple things about segments, and things that you guys already know, but are properties that we're going to use in proofs. And so these are going to be the first real geometry proofs that we're going to do. First big property that we're going to use is segment addition. And basically what it says is that AB plus BC equals AC. So the thing is, a lot of people get segment addition and regular addition confused. Alright, here's the difference. Segment addition is basically two things that equal one. Regular addition, you'll see two things equal two things. So like this case, we have AB plus BC equals AC. So you have 2 equal 1. Regular addition would be like AB plus BC equals XY plus BC. We have two things on both sides. So don't get those two confused. Segment addition, we have 2 set equal to 1. And basically we use that to show, okay, if we have a segment that's really comprised of two different things, this whole thing is really this part plus this part. Alright, next one. Definition of a midpoint, and what it is that if we say X is a midpoint, of let's just do AC or AB, we can say that AX equals XB or BX, it doesn't matter. Now here's the thing about this. The definitions can work conversely, and if you guys remember from the last section, conversely means back and forth. So if we are trying to prove that it's a midpoint, if we found out that AX equals XB, we can say it's a midpoint, or if we know it's a midpoint, we can say AX equals XB. We can work both ways. Definition of congruency. Now we're going to keep technically this is definition of segment congruency, and we'll learn about angle congruency, but they're basically the same thing. We're saying that if XY, segment XY is congruent to segment AB, that XY, the measure of XY, equals the measure of AB. Now this is an important one because what we need to know is, well, first they can go back and forth, but we can only do math when it's an equal sign. We cannot do math when it's congruent. We cannot add or subtract congruent signs. All we can use with congruency is substitution. If we want to add two segments together, we need to make sure that it's equal, and we can't have a congruent sign. So now that we know that, let's go ahead and try to do a proof. What we have here is given that AB is congruent to CD, so this segment, and one thing good to do with proofs is to mark segments, so those two are congruent. We want to prove that AC is congruent to BD. So basically, one thing before we even get started, we know, okay, those two little segments are congruent, and they both share this middle piece. So all we need to do is prove that the bigger parts are equal to each other. Let's get this started. So we have our two-column proof, and just like any good proof, we're going to restate the given. So AB is congruent to CD. And the first reason is given. Alright, now with this proof, we're dealing with congruency, and we can't just substitute in. We're going to have to add that middle piece. And to add anything, what we need to do is change it from congruency to equal sign. So we're going to say, well, AB equals CD. And the reason, that's the definition of congruency. Now I abbreviate a lot because we are writing a whole lot with proofs. So now that we know that they're equal, we can start adding. They both share this middle piece here, so I'm going to add that to both sides. AB plus BC equals CD plus BC. And when we add something to both sides, just like how we did with algebra, if we added 5 to both sides, that is just addition. Alright, next step. Well, what is AB plus BC? And what is CD plus BC? We should state that is. Well, AB plus BC, that equals AC. If we look at a picture, AB plus BC equals AC. Now we could do a whole nother step, but since the next thing we're going to do CD and BC, let's just state that CD plus BC equals BD. And the reason? Well, this is segment addition. You can just do segment add. That abbreviates it. Alright. So AB plus BC equals AC. CD plus BC equals BD. Well, let's look. Well, we know that equals that. What we can do is replace AB plus BC with an AC. We can replace CD plus BC with a BD. So step 3, we can replace both the left and the right side. So AB plus BC becomes AC. CD plus BC becomes BD. Because we know that they're equal to in step 4. So step 5 is substitution. And remember, way at the beginning I told you guys substitution. If you're ever confused, use substitution. It's kind of one. If you're ever out of, if you have no clue, just guess substitution. It's used a lot. All right, now if we look at a proof, we want to prove that segment AC is congruent to segment BD. We know that they're equal. Well, if we want to say that they're congruent, all we need to do, knowing that they're equal segments are congruent because of, well, right what we said in step 2, definition of congruency. So a lot of times with definition of congruency, you start out saying it, do some math. So you start out saying it, do some math, and then say it again at the end. Let's try one more, a little longer. Alright, we know that AE plus BD, or AE is equal to BD. So this segment is equal to that segment. C is the midpoint of AE, C is the midpoint of DB. We want to prove that AC is equal to CD. Alright, well, let's get our columns out. And first thing we do is rewrite the given. I'm going to try to write this small. AE equals BD. C is the midpoint of AE. C is the midpoint of DB. And the reason is given. Alright, well, what we're going to do, and always one thing you want to get a hang of doing, is looking at proofs, and their givens will help you figure things out. Well, there isn't much we can do with AE and BD right now. There are a couple things, but one thing that we might want to do is that, let's start with the midpoints. Since C is the midpoint of AE, well, we know because of midpoint we have two equal segments, so that AC equals CE. And that's because of the definition of a midpoint. Step 3, well, what we can also say is the other side going with DB. we can say that CD equals CB. And that is also definition of a midpoint. One thing that you guys could do, and you definitely won't get deducted points if you do this, notice how step 2 and step 3 have the same reason? What you could do is combine them into one step and just say AC equals CE, CD equals CB. You can do that. It's just sometimes easier once you get the hang of proofs to do that. Alright, well now that we know that, let's start talking about, well, AE. AE is those two segments together. So let's state that. That AC plus CE equals AE. And let's do the exact same thing with the other side. CD plus CB equals DB. And the reason, well, you're taking two parts, make it equal to one. That is segment addition. Alright, step 5. Well, we know right at the beginning AE is congruent to DB, so we can replace with the longer parts. So AC plus CE equals CD plus CB. And when we replace, it's substitution. I'm going to have to continue this on the next page. Okay, continuing, if we look at the chart, we know that AE and CE are the same thing. So let's replace, for our proof, because we just want AC and CD, let's replace the CE with another AC since they are equal. So AC plus AC equals, well, we want CD in our proof plus CB is equal to CD, so we can say CD. And when we replace, that is substitution. Well, let's simplify this algebraically. AC plus AC gives us 2AC. CD plus CD, it gives us 2CD. And that is also substitution. We were simplifying. Now, if I want to get AC by itself, I could divide, and I could take 2AC and divide it by 2, as long as I take 2CD and divide that by 2. And back in algebra, we learned a property of just dividing, and that is division. And lastly, we can simplify, and which is what we're trying to prove, AC equals CD. And the last step is subs. There you guys go. Good luck on this section.